right? No. Similar triangles, as we know, are same shape, different size. Same shape, different size. Okay? And there's only going to be three ways they're going to be used to show that they're similar. You get the triple A, which means all the angles in one match up with all the angles of the other. And actually, we're going to see this is only a double A. We got the triple S. It doesn't say all corresponding sides are congruent. It says all corresponding sides are proportional. And the SAS. Okay, and we'll illustrate these. All right, this is actually the angle. If any two angles of a triangle are congruent, two angles of another triangles are congruent, or excuse me, not congruent. Triangles are similar. Okay, here's your similarity symbol, and you don't even have to show the third one. All right, because if two are similar, the two angles are congruent. The third is congruent. So, with that, you could say, oh, all 30, 60, 90 triangles are similar. All 45, 45, 90 triangles similar. All equilateral triangles are similar. Okay? So, next we have if the sides are in a constant ratio with each other. Okay? So, if we can determine a three-way ratio between all the sides and the corresponding sides of another triangle and see that they're consistent, then you have similar triangles. So, like a 3, 4, 5 and a 6, 8, 10 are always going to be similar. A 3, 4, 5 and a 30, 40, 50 are always going to be similar. 5, 12, 13, 10, 24, 26 will always be similar. Those are the two we're going to see most. Here's another one. Okay, side angle side. Again, the angle between the two sides. All right, two angles of one are going to be congruent to two angles of the other. So here we're going to say angle A and angle X are said to be congruent. Then the sides that we need to show proportional are AB to XY, as AC is to XY. Okay? So, the first two are going to be ones we see most often. Then we can write the statement, triangle similarity. Again, the statement says it all. Which angles correspond, which sides are proportional. Okay? All right, let's take a look at a few. Now, okay, we give you some information. We say, are the triangles similar? And, well, the information given is that AB and DE are parallel, which means, as always with parallels, we're looking for congruent angles. In this case, alternate interior. Meaning B and D, A and E. Now that's it right there. Because all we need is two. So, you got it. Of course, you could have mentioned that the vertical angle here is not needed. Similarity by AA. You might even call it just by AA. Okay. Okay, so here we have one triangle kind of embedded in the larger triangle. Because we have that the midpoint of the sides are given, right? And so there's a couple of things that we could argue, okay? Well, if it's the midpoint, then there's a 1-to-2 ratio between GI and GF, as is between GJ and GH. That, along with the shared angle, would suffice, okay? So here's our 1-to-2 ratio. G is shared, so we have this SAS illustration of the triangle similarity. However, it's not always, I mean, there was an other option in that we're having, this is a mid-segment, which, as we know, is also parallel, okay? Which, it being parallel, is setting up corresponding angles, okay? Which is yet another way of illustrating, okay? Should have here AAA, not triple S, okay? All right, here we go. Determine the method by which the triangles are congruent, all right? Well, again, we have parallels. Parallels set up congruent angles, okay? 3 and 4, 1 and 2, shared angle, they're similar, AAA. We'll look at some examples.